Hello, Midnight Coders, and welcome. Every great app started out as an idea, and Java is one of those languages that lets developers turn those ideas into software used by millions. Hello, I am Glave, and I've been working with Java for over 20 years and built this channel to share my experiences and knowledge. So imagine writing a single application just once and then having it run everywhere. Mac OS, Windows, Linux, Raspberry Pi, mobile devices, Internet of everywhere, everywhere. Have it in your toaster. That is the one reason, or one of the reasons, Java remains one of the most popular programming languages for nearly 30 years. Some of the well-known systems and tools that are built with or heavily use Java include things like IntelliJ IDEA, Minecraft, RuneScape, and much others. Now, where does it run? Well, it runs on mobile devices, it runs on servers, desktop apps, command line. It runs just about everywhere. There's really no way, nowhere it doesn't. That's why it's right once run everywhere. So today I'm going to explain what Java actually is, why companies still rely on it, and why I think it's one of the best languages for new developers to get their feet wet. One of the reasons I keep coming back to Java for more than 2 decades is how it models reality. So I see things as models. When I build software, and for that matter, of the context, whenever I think about the real world, I see things as models and patterns. So Java helps me vision everything that I interact with as if I was interacting with software or real world. It jumbles back and forth. So when it comes to my code, I don't think in the terms of lines of code, but rather in objects, variables that make up these objects, like a tree, an ATM machine, or even the coffee that we drink. Um, the methods in which that we interact with these objects and things, and what I can do with that object. So let's picture a person. I am an extension of a human. I have a name, an age, a gender, skin and hair color, and a few other things. And these are public variables that people can see about me. Then I have some of those protected values that only my family know about, and as well as some private secrets that, of course, only I know about. In Java, we don't usually expose these variables directly. Instead, we control access and by declaring the variables private, and then we use public methods such as getters and setters so that we can control how these fields are modified or read. So Java classes have variables that you can declare as public, private, or even protected, um, as well as you have methods that say how you can interact with this object. If that makes sense, hit that thumbs up button. Now, what exactly is Java? Java is a high-level, object-oriented programming language built for reliability, scalability, and portability. It works by compiling code into bytecode that then runs inside of a Java virtual machine or JVM, which allows the same program to run across different operating systems without any modification. So at its core, Java models software around objects, which are self-contained units that combine data and behavior, making it easier to structure and maintain complex systems. So modern Java has evolved significantly, offering cleaner ways for you to write code and much more powerful features while still remaining the backbone for just about everything on back-end large-scale systems. Now, I want you to understand why this matters today. With all the different languages that are out there, I want you to understand why it matters today. And more importantly, why I keep coming back to it. So, in order to do this, we need to hop in our little TARDIS and go back in time. So, why why was Java why does Java exist? Back in the 1990s, software usually had to be rewritten for every system that it was going to be ran on. So you had to write a copy for Windows, a copy for Mac, a copy for Linux, a copy for mobile. It it would have been frustrating. Not that mobile was around in the 90s. But anyway, you had to write a different version for different things. Java solved that problem by compiling the code into bytecode instead of native code. And then the JVM runs the same compiled bytecode on any system that has a compatible JVM installed, whether that be Windows, Mac, Linux, servers, the cloud, whatever. Doesn't matter. This is why Java is write once, run anywhere. So now, why is Java still everywhere? Java is still everywhere in 2026 because it powers the systems that can't afford to break. If you've ever opened up a banking app, processed a payment, or transferred money, there's a strong chance that Java is running the back end that makes that system secure and reliable. Most modern apps that you use daily are built on top of cloud services and or microservices, which are Java, especially with Spring Boot. Uh, this is still one of the most common choices for API authentication and large-scale backend systems. Even in big tech companies, Java quietly runs infrastructures like data pipelines, search systems, and internal services that need to handle massive traffic without failing. That's the key part. Now, the key idea is simple. Java didn't stay relevant because it was trendy. It stayed because it was stable, scalable, and trustworthy, where failure is not an option. Now, I mentioned earlier object-oriented programming. What in the sweet hell is that? So let's imagine a video game where there's a player that has a name, has some health, has an inventory, and a few other things. Now, they also have the ability to attack, move, eat, or some other options or actions. So now, let's model these things as if they were real objects. Okay? You would then have so okay. Let's think about encapsulation. Let's talk about encapsulation. Because some of the four pillars of object-oriented programming is encapsulation, abstraction, polymorphism, and inheritance. So, for encapsulation, let's think of a pill that your doctor has prescribed. You don't see the internal interactions with the chemicals. You don't interact with the chemicals inside. You just take the pill and trust it's going to get the job done. In Java, the data is hidden inside of a class, and you only ever interact through a controlled method such as a getter or setter. Now, inheritance, this is sort of like your family. Your child may inherit your eye color, your height tendencies, or even your hair color. In Java, a child class inherits the parent's fields and methods, uh, but these can be customized per child. Uh, abstraction, well, abstraction is when you learn to drive a car, you don't think about how the engine combusts fuel or how the transmission switches gears automatically. You just use the steering wheel and the pedals to interact. In Java, you interact with a simple interface, and the complex logic is hidden behind the abstraction layers. Now, what about polymorphism? Polymorphism. Think about booking an appointment. You have a very simple task. You just want to reach out to somebody and book an appointment for something. So, maybe you're looking to book a flight for a vacation. Maybe you're looking to book time with your mechanic. Maybe you're looking to book an appointment with your doctor. Maybe you're looking to book an appointment with your Java consultant. You make the same type of request. However, the system routes it to a different implementation depending on what it is that you're interacting with. Now, in Java, you can call the same method, for example, book appointment, but the actual object, whether that be the flight associate, the mechanic himself, or your doctor's office, the object itself determines its own implementation. Now, if you've been thinking about learning programming, Java is a great place to start. And once you have the basic fundamentals down, struggled there. Once you have the basic fundamentals down, you can then move on to my website, midnightcoder.dev/challenges. Challenge. And the link will be in the description. You can get yourself a challenge and start building your own apps. So, make sure you've got that full cup of coffee. Crack open your favorite IDE, which for me is IntelliJ, and let's get ready to check out some Java.